Yeah, thank you for the invitation, and I'm very happy to present a short webinar for talking about the advanced methodology for integrating the crowdsourced environmental data with the remote sensing technologies. So and today we are going to spend a lot of sort of time talking about how to integrate citizen science with remote sensing data. So at the beginning, I want to share the official definition of what is citizen science. So the citizen science is defined by the let me close the tab. Yeah. So the citizen science is defined by the scientific research that conducted in a whole or in a part by the amateur or non-professional scientists. So in a lot of the time that you can also see the citizen science mentioned as crowdsourced data and volunteer geography mapping and also like participatory mapping as well. So in the United States recent year, there have been to a lot of the attention to support citizen science program. For example, like NASA Citizen Science Division, Citizen Science at NOAA, USDA, and also at EPA is called the Participatory Science for Environmental Protection. So, um, because we really want to bridge the gap between the scientific research to the public sector. There have been a lot of rise in the recent 2 decades for the rise of the citizen science platforms and the data as well. So for the one of the most contributor for the global biodiversity or any biodiversity observations, there's a platform, the major platform they call the Global Biodiversity Information Facility, which is short in GBIF. So in this line, we can see on the right side of the screen, we are seeing two lines that on the bottom is the contribution of the citizen science database. So in the by the year of 2020, the number of the observation data already reached to a billion. So and by the year of 2016, the citizen science data already contribute more than 50% of the whole biodiversity database. So that is a very large contribution for all those like environmental monitoring data. Um, and all those, like in all the citizen science platforms, there are several major contributors. For example, like the eBird, iNaturalist, and the Swedish species observation systems in the Swedish. So, and also there are like also numbers of programs that increasing the last 2 decades. So on the left side, we are showing that the number of the program every year. So for the citizen science projects are like hundreds, thousands numbers of levels. So today we are going to spend some time talking about two platforms. One is called iNaturalist, the other one is Citizen Science Global Observers. So, and in a lot of the cases, when you are trying to do the research, if you want to use citizen science data, you might challenge the values of those data. So as a geographer, we also we are trained to host a volunteer geography mapping in the connection into a lot of different disciplines. For example, like the social geography, transportation, disaster management, climate and environment. So a lot of the cases, because the citizen scientists are in the have a lot of valuable local knowledge of the data. And so the quality of the citizen science data that collect by the volunteers are like on a project by project basis are actually better than a lot of the data that collect by the expert. And the amount of the data that collect by the citizen science are much more like exponentially more than what is how like the local expert no the expert researchers can collect in a short of period of time. So like how we can make the optimal use of the citizen science data. So here is research that we have for like really trying to quantify the data quality of the crowdsourcing data. So imagine that we have like a small amount of expert and a large amount of crowd. So, and the great idea for trying to take advantages or make the best use of the citizen science data is to give the citizen scientists like trainings. So really make them to understand how to standardize the data protocol, for example. And we can see that by trainings, set different trainings, the citizen scientists, the treated crowd can reach like a really great level of accuracy, collecting those data as well. So, the iNaturalist is a citizen science platforms that we use them a lot in the daily life. So, for example, if we want to, we saw a species that we can take them a picture and upload by the cell phone. And so those pictures are gonna be automatically recognized by AI for the species, and then um, and also the citizen science themselves are also assessment platform. So that will be like a greater search level user that can say, oh, here, the species definite identification is right or wrong. So here on the right side is actually a study that we've done before for the massive birth mortality project. So the story came from like 2020, the year of 2020. There has been a giant wildfire that in the western United States in August and September. So that a wildfire taking for 2 months and was ended by a snowstorm that in the summertime. So and after that summertime, the people start to observe like that bird in the backyard, hundreds of that bird everywhere. So the citizen scientists in an iNaturalist start to organize AVM mortality projects. So we've been able to collect thousands of observations in the so in a period of time. So and then we really want to use a remote sensing. We really want to use the remote sensing Earth observations in combination with the geospatial models to find the drivers of what are the really drivers of those massive death birds. So here we collect the data. We collect 21 environmental covariates from the Earth observations. For example, like the wildfire occurrence, air quality, droughts, and many other different variables. And by different phases, here are the major events are snowstorms and wildfires, and with no like nothing. So we use GWR, the geography weight regression models, to see, oh, there really are like different based on the coefficients distributions. So we're going to be able to see what are the really drivers for the birth mortality data. So we also like after that we also see, oh, there are several major species that are like stand out in those massive birth events. So we went down into the species level to build a special machine learning algorithms. um, Here we see for different bird species, what are the major drivers for those massive death birds by using the citizen science observation data. So, and here are several examples. So we studied the Wilson Wappler and also like a barn owl. So different like major species have the different behavior. And the other citizen science platform that I want to introduce is the Globe Observer. So the Globe Observer is founded under NASA, and it has ability to collect the data for more than 60 or 80 different parameters. And it covers like atmosphere, biosphere, hydrosphere, soil, and Earth system as a whole. So, and the one there, like the NASA Globe Observer is very famous for their standardized, well-designed protocols. So today I'm going to talk about the land cover and mosquito habitat. So in the Globe Observer, you can see how that strategy works out. So the citizen science contributes data to the Globe Observer team for photo review, and then all those data goes to the global program and NASA. So and also like after the all those data reviews and everything, those raw data go back to the citizen science to download. So all those data collected by the citizen scientists are also open to all the citizens. So that is like a great values for the equity of the data. So, the global observer for the land cover data has a unique protocol for measuring 6 different directions. So, by taking the photo from north, south, west, east, up and down, so it really has a feeling of like hosting a 600-degree ground view. And so on the right side, that is an example of what we are really collecting by the cell phones. And so here we are reclassify those to different categories. So how we actually incorporate AI into the Globe Observer land cover is we really want to try to quantify if like those 6 different views are the accuracies are much more better than any of like one single lung cover image. So we collect the multi-view lung cover classification in the global. So we can see here the global scale. So we can see here the distribution of those lung cover classifications are like we can see that there are several major contributors. For example, like the United States and the Euro, for example, as well. And so in this study, we collect 9,200 samples for all full directional with all those label information. Um, we also like so how we actually do it. So here is a framework, and so we used the 4 different views. So we didn't use up and down. We developed 3 different methodology um, of the fusion technique to fuse those different views. So they call the early fusion, late fusion, and the square fusion, and so the early fusion is type of we fuse the 4 different views at the beginning and then we merge them together. And the late fusion is um, like the other way of the early fusion is that we fuse the results at the end. And the score fusion is kind of like the late fusion. So we give them different scores for the features and then we future the scores at the end. So, and here we are gonna be, the result is showing that uh, we are using 4 different machine learnings to classify the lung cover classes. We use the VGG, ResNet, MobileNet, and EfficientNet. So here we can see that on the left side, all those, it really can be short into one sentence that the more views, the better. And then we are also checking into separate early fusion, score fusion, and late fusion, how those different fusion technique behave in the results. So we can see that in a lot of the cases, actually, in the early fusion, uh, it's like the second wheel sometimes the are like double view are not really well. So, but it's still like all the 4 different views are behaving the best. So we are also doing a lot of protocol improvement. So for example, this is an like a results combination for original view and also attention overlay. So it means like the higher, like the more red, the color in the red means that you have the high level of attention level to decide which classes those uh like image belongs to. So we can see that here they are like actually making a great contributions to the classification protocol of the NASA Globe Observer. So the other protocol that I want to talk about is called the Mosquito Habitat Mapper. And here like you just need to download the app and then take a training like 10 minutes and then you'll be able to contribute the mosquito habitat mapper and land cover data here in the cell phone. So, and the unique advantages for the global mosquito habitat mapper is that it really brings a lot of the image that is showing the microhabitat, which is really like difficult for the researchers to take. For example, in the middle, we are taking the pictures of where actually the mosquito habitats are, like the small pond in your backyard, the containers as well. So on the right side is shown, we are showing the distributions of all those mosquito habitat. So the microclimate habitat is also like the linkage connection between the Earth observation, like remote sensing data, to the ground truth data as well. So, and a lot of cases, if we want to study mosquito habitat to increase the data density, so we are really calling the public attention to contribute the data into those platforms. So what we really want to fight against the spatial, um, like the data consistency. So we will develop, uh, like the BME approach, the Bayesian maximum entropy approach, to like apply those into the global data sets into a continuous surface. So here are some basics, like the three-step of the BME process. Um, I'm not gonna introduce in more details, but that is like we are gonna use the AI machine learning methodologies to um, like simulate the global data set and trying to make it connected to the NASA uh, Earth observation data as well. So, and the outcome will be statistically compare surfaces that between the globe and NASA observation. So this will be a great contributions to both the ground truth data set and as well as the Earth observations. So we've been also doing a lot of the dashboard developing based on using machine learning and AI. So for example, the Global Observer Data Explorer, we are combining the ground truth data with a national land cover data, national NLCD, national land cover data set. So by giving them scores and showing that on the portal, we will find like what are the locally really great level of the ground truth data. So, and the total observations nowadays already increased to 30,000 observations. So that's a great data set for ground truth validating. And also, we've been developing mosquito habitat observers as well. So here we can see those are just 1 month in like just one like 20 years of data in the United States. So we can see that this is like how we are gonna map the data in monthly and also the seasonally and yearly patterns. So, and here we can also like in the dashboard, we show the mosquito habitat, community contributions, and also the mosquito counts. So and all those are in the global level and the data are public free and for download. So here are some take-home messages. There will be a lot of like power for collaborations in the future. So the Citizen Science Network really like amplifying the impacts across Americas, and also I want to try to give a call for anywhere like the citizen science crowdsourcing data can make a very positive impact. So, and also like this is uh, like related to everyone, like everyone can make contributions as well. And by integrating. So we are gonna be able to develop some very great framework by AI machine learning to reuse those citizen science networks in the science. So thank you so much for joining today, and be happy to take questions later.